Hi again. Radicals lesson 3, multiplying and dividing radicals. So the first example is multiplying square roots. Here, your best bet is to multiply all of this together. And what you'll end up getting is square root of 36 x to the 8. You don't have to break this down because this is already a perfect square. So the square root of 36 is simply 6. And now square root of x to the 8, as I said, 8 divided by the little 2 here is 4, so that makes x to the 4. So the final answer is not a mixed radical because all of it is a perfect square, so just you get this. If we do in division, your best bet is to start reducing. So 5 reduces gives you 1, and 25 would be 5 because 5 goes into 25. 5 times. And then here you could divide it right away. So you'll have basically this divided by this gives you square root of 9x squared. And you still have the 5 underneath here. So basically what I did, I just reduced, this goes into itself once, it goes into 18x cubed, 9x squared times under the square root. And that's how I get that then. You still have to keep the 5 on the bottom there. And this also, 9 is a perfect square, x squared is a perfect square, so you don't have to do mixed radicals because you could square root all of this, and the square root of 9x squared is just simply 3x over 5. How about dealing with the cube roots? This, first of all, I could see that I could do the cube root of 8 right away. So, because since it's a perfect cube, I could just make this simple and make it 2 the cube root of x squared, because I cannot cube root the x squared, times cube root of 54 x to the 7. Now you can multiply it right through, so you'll end up with 2 cube root of 54 x to the 9, which gives me the cube root of x to the 9. I could do right away because 9 divided by 3 is 3, so that makes it x cubed. And the 54, I'm gonna break it down because from the cube roots, 27 goes into 54 twice. So I'm just gonna change the 54 to 27 times 2. And the cube root of 27 is 3. So 3 times 2 is 6. We still have the x cubed there. And then the 2, we don't know what the cube root of that is. So we're just gonna keep it as cube root 2. And that's mixed radical cubic function. Final answer. We're gonna move on to the next example, dividing cube roots. The best thing is to reduce here. So you divide this by itself, it gives you 1. You divide this by the cube root of 3x squared, it gives you the cube root of 8x to the 6. So basically we have 1 over cube root 8x to the 6. This is a perfect cube right here. Both of them, the 8 and the x to the 6. So simply this will simplify, and the cube root of 8 is 2. Cube root of x to the 6 is x cubed. So the final answer is 1 over 2x cubed. And now we have 3 more questions with the distributive property, the foiling, and also this squared. Also, this is foiling, and I'll come back to this. For this, it's very simple. Just distribute here and there. So 3 times 5 is 15. 2 times 7 is 14. So this would be 15 root 14. Minus 3 times 4 is 12. Root 2 times root 3 is 6. And this one, this is as far as we could go. And the reason is none of these perfect squares go into any of these numbers. Okay. So if they don't go, none of these perfect squares go into these numbers, then you cannot do it. You can just, this is the final answer. Then we'll go to this, and this is foiling. So 2, so you go first times first, first times second, and then second times first and second times second. So 2 times 2 is 4. 2 times positive root 3 is plus 2 root 3. Negative root 3 times 2 is minus 2 root 3. And negative root 3 times positive root 3 is negative root 9. And root 9 is basically 3. So I'm just going to take that shortcut. Yeah. This will cancel. And then you just have 4 minus 3, which gives you 1. Okay. One thing I want to bring to your attention is if you multiply a radical by itself, so radical 7, square root of 7 times square root of 7 is simply 7. Yes, it's square root of 49, but square root of 49 is 7. So you could take a shortcut when you do root 7 times root 7, just write 7, that's the answer. You don't have to go through this process. And also when you're foiling, if you look at this brackets and this brackets, they are the difference of squares basically. So you could almost, you don't even have to foil in this case, just multiply first by first, and then second by second, and you don't have to go through this, and then you end up with just 4 minus 3, which is 1. Because you know the middle is gonna cancel when it's the difference of squares. The third one, some students when they see this, they go square this and square this. No, square here means the brackets is squared, which means this bracket's multiplied by itself. So you have to rewrite this as root x plus 2 root 5, again root x plus 2 root 5, which equals root x times root x, as I mentioned here. If you multiply a root by itself, just get rid of the root. So this is simply x, or you could write root x squared, which is x anyways. And then root x times 2 root 5 is going to be plus 2 root 5x. And this here will give you the same thing since it's the same thing again. So it'll be 2 root 5x plus 2 times 2 is 4. And root 5 times root 5, as I mentioned, you could just say that's 5. And these two numbers are multiplied. So therefore, if I'm going to simplify this further, this will be x. These are like terms, so you could add them. So you'll end up with 4 root 5x. And remember, we don't add what's inside. We just add the coefficients of the roots. And then 4 times 5 is 20. Check, that's your final answer. Next thing we're going to do rationalizing denominators. I'll see you soon. Stay safe.